Background and history. Mercury's prelude, the need for rigorous testing of the Mercury spacecraft. 1. The burgeoning space race demanded meticulous testing of the Mercury spacecraft to ensure the safety and success of manned space missions. 2. The Little Joe rocket program emerged as a response to the imperative for comprehensive testing in the early days of human spaceflight. Little Joe's origins, designing a specialized rocket for Mercury testing. 1. The Little Joe rocket, designed by NASA and its contractors, was a unique launch vehicle tailored for suborbital testing of the Mercury spacecraft. 2. The program aimed to simulate various launch escape scenarios and assess the spacecraft's performance under different conditions. Test rigorousness, the comprehensive nature of Little Joe's testing regimen. 1. Little Joe was not a single mission but a series of tests, each designed to scrutinize specific aspects of the Mercury spacecraft's behavior and response. 2. The program played a crucial role in building confidence for subsequent manned Mercury missions. Historical impact. Mercury's stepping stone, Little Joe's contribution to human spaceflight. 1. The success of the Little Joe rocket program directly contributed to the advancements of the Mercury program and, consequently, the entire human spaceflight endeavor. 2. Little Joe provided valuable insights that paved the way for safe and successful manned space missions. Confidence builder, boosting morale and technical understanding. 1. Little Joe's successful tests bolstered the morale of the teams involved and provided vital technical data to refine and improve the Mercury spacecraft. 2. The program's achievements played a pivotal role in shaping NASA's early reputation for rigorous testing and reliability. Astronaut training, Little Joe's impact on astronaut preparedness. 1. The data gathered from Little Joe tests influenced astronaut training, ensuring that spacefarers were well prepared for potential emergency scenarios. 2. The program contributed to the overall safety and success of manned space missions. Historical milestones. Little Joe 1, the inaugural flight testing the launch escape system. 1. Little Joe 1, launched on August 21, 1959, was a crucial test of the Mercury spacecraft's launch escape system. 2. The successful mission validated the effectiveness of the launch escape system in ensuring the safety of astronauts during launch. Little Joe 5, testing the spacecraft's response to high-altitude aborts. 1. Little Joe 5, launched on November 8, 1960, focused on testing the spacecraft's behavior during high-altitude aborts. 2. The mission provided critical data for understanding the spacecraft's performance in various emergency scenarios. Little Joe 6, qualifying the spacecraft for orbital flights. 1. Little Joe 6, launched on May 9, 1961, was a pivotal mission that qualified the spacecraft for upcoming orbital flights. 2. The successful mission paved the way for the historic manned Mercury Redstone 3, Freedom 7, mission by Alan Shepard. Technological advancements. Launch escape system, perfecting the crucial safety mechanism. 1. Little Joe played a vital role in refining and perfecting the Mercury spacecraft's launch escape system, ensuring astronauts' safety during the critical moments of launch. 2. Advances in launch escape technology influenced subsequent spacecraft designs. Aerodynamic studies, understanding spacecraft behavior at high altitudes. 1. Little Joe missions involved extensive aerodynamic studies, providing crucial insights into how the spacecraft behaved at high altitudes and under various conditions. 2. This knowledge was instrumental in designing spacecraft with optimal aerodynamic performance. Parachute systems, testing and improving descent and recovery mechanisms. 1. Little Joe missions included rigorous testing of parachute systems, crucial for the safe descent and recovery of the spacecraft. 2. Advancements in parachute technology influenced the design of landing systems for future manned missions. Challenges and risks. Technical hurdles, overcoming engineering challenges in rocket development. 1. The development of the Little Joe rocket presented unique engineering challenges, requiring innovative solutions to meet the testing objectives. 2. Overcoming these technical hurdles was essential for the success of the program. High-stakes testing, the pressure of ensuring mission success. 1. Each Little Joe mission carried significant stakes, as success was crucial for progressing to manned Mercury missions. 2. The pressure to ensure mission success required meticulous planning and execution. Safety concerns, addressing potential risks to astronauts and equipment. 1. Safety was a paramount concern in Little Joe testing, with a focus on minimizing risks to both astronauts and the spacecraft. 2. Addressing safety concerns required continuous refinement of systems and procedures. Future prospects. Legacy in testing, Little Joe's influence on subsequent spacecraft testing. 1. The methodologies and lessons learned from the Little Joe rocket program continue to influence spacecraft testing and validation processes. 2. Little Joe's legacy is evident in the thorough testing protocols employed in modern space programs. Advancements in safety, Little Joe's impact on improving spaceflight safety. 1. Little Joe's contributions to spacecraft safety systems and protocols have played a lasting role in enhancing the safety of manned space missions. 2. The program's influence is seen in the continuous advancements made in safety technologies. Continued innovation, Little Joe's role in fostering a culture of innovation. 1. The culture of innovation fostered by the Little Joe rocket program continues to drive advancements in space exploration technologies. 2. Little Joe's legacy lives on in the spirit of innovation that characterizes the ongoing quest for exploring new frontiers. Controversies and debates. Test parameters, debates on the adequacy of test scenarios. 1. Some debates surround the adequacy of certain test scenarios conducted by the Little Joe rocket program, with discussions on whether all possible emergency scenarios were sufficiently addressed. 2. Evaluating the comprehensiveness of test parameters involves considering the evolving understanding of spaceflight dynamics. Resource allocation, balancing the need for rigorous testing with limited resources. 1. The allocation of resources for the Little Joe rocket program raised debates on whether the testing program received adequate funding and attention compared to other aspects of the Mercury program. 2. Balancing resources required careful consideration to ensure the success of both unmanned testing and manned missions. Public perception, shaping public perceptions of space exploration. 1. The level of transparency and public communication during the Little Joe rocket program sparked debates on how much information should be shared about the testing process. 2. Public perception debates involved finding the right balance between transparency and national security considerations. Additional information. Behind the scenes, the unsung heroes of the Little Joe rocket program. 1. The success of the Little Joe rocket program relied on the dedication and expertise of a diverse team of engineers, technicians, and support staff. 2. Exploring the stories of these unsung heroes adds a human dimension to the technological achievements of the program. Little Joe variants, exploring the different configurations of the Little Joe rocket. 1. The Little Joe rocket program involved multiple variants, each tailored for specific testing objectives. 2. Understanding the nuances of each variant provides insights into the adaptability of the program. Educational impact, Little Joe's role in shaping aerospace education. 1. The Little Joe rocket program has become a valuable educational tool, offering insights into the complexities of rocket testing and spacecraft development. 2. Educational initiatives associated with Little Joe contribute to inspiring the next generation of aerospace professionals.